In this video, we'll be focusing on graphing trigonometric functions. This series of videos will come in several parts because of the volume of the material. There has already been a couple of videos on building the unit circle, which is really an important skill. If you haven't watched the building the unit circle video, it may be helpful to do so before watching this video. All of them can be found on my channel, which is Melody Educate on YouTube. You can also find links to my videos, some of my videos, through my website, www.melodyelrod.com. So let's go ahead and get to work. When graphing trigonometric functions, it's very helpful for us to reference the unit circle. In the unit circle, we've already learned that a right triangle can be built at any of these points. Let's build it right here. Let's build this right triangle at the origin. And again, this is part of the building building the unit circle video as well. And we'd put theta right here at the origin, or right angle here. And in a right triangle that is built inside the unit circle, we have great confidence in calling the hypotenuse 1 anywhere we draw this triangle. We can also know that the base of this triangle will measure x, the distance between the origin and the place where we begin to build up towards the point that's on the circumference here. So we have x here, and then the height is y. Because to get to this point, this xy up here, we must go to the right or to the left, x, and then up or down, y, to get to this point. So that gives us the triangle x, y, and 1. Now, let me turn off the unit circle for a minute here. What that also tells us is that in order to find the sine, cosine, and tangent of values that are inside the unit circle, all we have to do is to look at this triangle. The sine of theta then is going to be the y value divided by 1. It's going to be opposite over hypotenuse, or just y. Likewise, the cosine value is going to be adjacent over hypotenuse, x over 1, or simply x. The tangent is opposite over adjacent, or y divided by x. And so these values are going to come in very handy for us in just a moment here. What we're going to do is we're going to study each of these in isolation. We're going to talk about just the sine of theta, just the cosine of theta, just the tangent of theta. So let's turn first to our sine values. The sine of these values, what we're going to do in the unit circle, it's cut quite nicely into nice pretty segments. We've got 2 pi, we've got pi over 2, pi, 3 pi over 2, and actually we started at 0. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so what I'm going to do is I'm going to isolate just this portion of the unit circle. And let's talk about just those points. Just the 0, pi over 2, pi, 3 pi over 2, and 2 pi of the whole thing. So we've got a point out here that is 1, 0, up here, which is 0, 1. We're going to really highlight these values, and this is what we're really going to study when talking about the sine and the cosine specifically of these values. Okay, so let's take the unit circle off, and let's look just at these points for right now. Okay. Okay. So when I look at the sine graph, what I'm able to do then is to realize my reference angles, if you will, the quadrant angles, are going to become those angles that are the most important to me. Pi over 2, pi, 3 pi over 2, and 2 pi. And we're going to go ahead and follow those in the negative direction as well, because one of the beautiful things about trigonometry is it's periodic. It just goes around and around and around. I told a joke in class the other day that, if you don't understand trig, don't worry about it because it'll repeat itself. Ha ha ha. Nobody laughed. I thought it was hilarious. But then again, I suppose I would. Anyway, so let's talk about the sine of x. Now, it's annoying to say the sine of x because we just got through saying that on the unit circle, the sine of x is y. But we're going to begin to look at just the sine in isolation, so we don't really need quite so many variables. Looking at the unit circle, the sine values begin at 0. At 0, the y value is 0. At pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it's negative 1, and it continues around that way. And so what that allows us to do is to say the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi, 0. The sine of 3 pi over 2, negative 1. The sine of 2 pi, 0. Okay. What's nice about this is if we follow the unit circle in the opposite direction and we look at it in this direction, then we find that same pattern to be true. At 0, it's 0. At negative pi over 2, it's negative 1. At negative pi, it's 0. At negative 3 pi over 2, it's 1. And at negative 2 pi, it's 0 again. And so these values will continue to repeat themselves. Take those off. So we're going to need this little graph again. I don't want those getting in my way. Okay. Okay, so we get to continue to the back. So we go down, back to the x-axis, up, and back down. And what this does is it makes a nice clean graph. Now for those of you who have not drawn a sine graph before, you may find it difficult to make a nice smooth line. I'm going to say this while I'm trying to draw this on my my tablet software, which is actually kind of tricky. But oh, that wasn't too bad. But what we know is this is going to continue in both directions. Now again, if you draw your graph and it looks like a bunch of pointy humps instead of rounded humps, that's okay. That happens the first few times, so don't sweat it. But we do know it's going to continue to the right and to the left, doing the very same thing, just up and down, because the sine graph is periodic. It's very akin to things like frequency for sound and for light and all of those other things. Okay. All right, so there's our sine graph. For our cosine graph, we can do something very similar. It's still going to be bounded by 1 and negative 1. And we're still going to use the quadrant angles, pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Still bounded by these values. These are still our reference angles. But what we're going to do now is when we look at this, we're going to be looking at the x value. So let's look at the x value for a moment. It's going to go from 1 to 0 to negative 1 to 0 and back to 1. So we've still got this oscillation between 0, 1, and negative 1, but this time we get to start at positive 1. So let's see what happens when we draw that out, what kind of shape we get to this graph. So this time we start at 1, drop to pi over 2, drop at pi over 2 to 0, down to negative 1, back to 0, and up to up to 1 at 2 pi. Okay, and then this is going to continue itself in the negative direction. We really expect, because we know from the sine graph that these are periodic, we really expect this to just go whoop, right back down. So let's double check and make sure that it does. Okay, so again, going in the negative direction, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. We're still going to have that oscillation, 1, 0, negative 1, 0, 1, 0, negative 1, 0. So that just continues on. Okay. So here we go so we started at 1, we come down to 0, negative 1, 0, 1. Okay. And this nice curve emerges again. I feel a little bit like Bob Ross saying, nice little curve, but whatever. You can even give it some little ears if you'd like to. We won't tell anyone. All right, enough of that. Okay, so here we go. These continue to the left and to the right. Okay, so there's our cosine curve. No big deal. Now, tangent, it's kind of a tricky little guy, and he's not going to look the same as his friends. We're still going to use the same reference angles. We're still going to use that pi over 2, pi, 3 pi over 2, and 2 pi. We're still going to use negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. But this time when we look at the graph, when we look at the unit circle, let's look at the whole unit circle again. I think that'll be helpful. Whoops, wrong one. Let's look at the whole unit circle again. The unit circle, we know that tangent, from this guy right here, we know that tangent is the y values over the x values. The y values over the x values. So what is happening to the y values as I move this way across the unit circle? The y values are growing 0, 1/2, rad 2 over 2, rad 3 over 2, and positive 1. But right here, 0 over 1 exists, and 1 over 0 up here at pi over 2 does not exist. So let's keep that in mind. Let's go back to our graph here, and let's keep that in mind. So we know at pi over 2, we've got 1 over 0. So tangent of pi over 2 is 1 over 0, which does not exist. In graphing, when something gets divided by 0, an asymptote appears. Okay? Which means that this is going to happen at pi over 2. And then let's see where else it happens. Let's go back to our unit circle, and let's see where else that happens. Okay, so we've got a 1 over 0 here. We've got a 0 over negative 1 here. Okay, so 0 divided by negative 1. Yeah, I can do that. So that's 0. And then down here, I've got negative 1 divided by 0. Again, bad things are happening. Rad 3, or excuse me, 3 pi over 2 is going to be another asymptote, which means that running backwards, okay, running in the negative direction, negative pi over 2 and negative 3 pi over 2 are also going to be asymptotes. So let's draw those in. Let's get those out of the way and make sure that we've got those on our graph. So we've got one here, we've got one here, and we've got one here. So in the positive direction, up at the top quadrant angle and the bottom quadrant angle, and the same thing happens in reverse. Now, we just said that in this first quadrant, okay, we know that the tangent of 0 is 0. And so that means that the tangent of 2 pi is 0 and the tangent of negative 2 pi is 0 because they all are the same place. Let's see what happens at pi. Let's just double check ourselves, make sure we're not just going every which way. All right, so at 0 and 2 pi, it's 0 divided by 1. But at pi, over here on the left-hand side, it's also 0 divided by negative 1. And that is going to be that is going to be 0. Okay, so that's good. We can do that. So we can say this is 0, this is 0, and so negative pi is also 0. All right. Now, this guy right in here, all of this area in here, this represents the first quadrant, moving from 0 to pi over 2. So let's go back to the unit circle, and let's see if we can reason this out. Okay, now on the unit circle, let's see what happens. Tangent is y over x, right? So we're looking for y values over x values. And that means that as the y values grow and the x values shrink, then that means that this whole fraction is going to grow. So we grow to 1/2, to rad 2 over 2, to rad 3 over 2, and finally to 1. So let's go to the tangent curve and see what that does for us. So that means that right here we're going to grow. And there he goes, just growing right up. Let's see what happens. Okay, now this right here, I kind of expect it to do this. Let's double check and make sure that's true. But I kind of want to say that in the fourth quadrant here, because that's what this is the fourth quadrant, that it's going to happen again, that it's going to grow in the negative direction. Okay, so it's going to kind of shoot down here. So let's see what happens. So here we are in the fourth quadrant, moving this way, right? So again, those y values are getting more and more negative. So I've got negative 1/2, negative rad 2 over 2, negative rad 3 over 2, negative 1. Those are getting bigger in the negative direction. And so yeah, I think I'm right. I think that this is going to go this way. All right. Let's see what happens. Okay, so if this is the first quadrant, right, then this has got to be the second and third quadrants. Again, let's see what happens. Okay, so in the second quadrant, my numbers start to get a little bit smaller. Or excuse me, nope, they're getting bigger in the negative direction, right? So I go from negative 1/2 to negative rad 2 over 2 to negative rad 3 over 2, right? These are all happening in the opposite direction, okay? And then I've got negative 1 over, or excuse me, negative 0 over 1. Oh, I just messed that up. Did you guys catch that? I was going with the x values. It's the y values I'm really interested in, isn't it? Okay, so we've got rad 3 over 2 down to rad 2 over 2 down to 1/2, except that I'm dividing the x value by the y value, which means that I'm going to get a negative. So I've got negative rad 3 over 2, negative rad 2 over 2, negative 1/2. And so those are actually getting smaller. They're getting closer to 0 from the negative side. So let's see what that looks like. Okay, they're getting closer to 0 from the negative side. Okay, and so they'll go up this way. All right, now we can see a definite pattern here, right? So I can trust that this will happen this way, and you can double check my numbers here, but this same pattern is going to continue to occur over and over again. Now, a period for tangent, how long does it take to repeat itself? Okay, let's talk about that a little bit. Down here with the sine curve or the cosine curve, we'll use the cosine curve. Down here in the cosine curve, how long does it take for it to repeat itself? Well, it goes down, right? Comes back up, starts to repeat itself at 2 pi. All right. What about the sine curve? The sine curve. We're here at 0. We go up. We get back to 0, but we're not really repeating ourselves because now we're going down. And then we come back up to 2 pi, and that's when we would have started to go up again. So it takes us 2 pi to repeat ourselves. So a period of sine or cosine is 2 pi. How long does it take for tangent to repeat itself? Well, we start here at 0, and we flare up. We get an asymptote, and we've flared down, and then we start to flare up again. So it only takes us pi to repeat ourselves. A period for tangent is just pi. That's not really information that you have to have right now, but it will be handy in the next couple of videos. Now, so we've talked about sine, we've talked about cosine, we've talked about tangent. We haven't talked about the parent graphs of secant, cosecant, and cotangent. And I want to do that now. I want to go ahead and include that in this video because it really doesn't take but just a minute to do. Once you have sine and cosine, cosecant and cotangent come really naturally. So let's put cosecant, let's start with cosecant. We're going to put it in a different color. Y equals cosecant. More different than that. Let's make it pink. Cosecant of x. Now, I pulled the sine graph back up here, and the reason that I did that is because cosecant and sine are reciprocals of each other, right? Cosecant is simply 1 over the sine graph, a sine function. And so if we want to use that information to graph it, we can. Now, we know we can't divide by 0, and so that means that everywhere that sine is 0, cosecant is undefined. And what happens when something is undefined in the graphing world? An asymptote shows up. So it's undefined right here, where sine is 0, and it is undefined right here, where sine is 0, and here. Okay, so we've got several asymptotes that are coming up, which means it's going to happen in the negative quadrants as well. Okay, now let's compare some of these other values. At pi over 2, sine is 1. So that means that cosecant is 1 over 1, and we know that to be 1. 1 divided by 1 is 1. Because they're reciprocals, where sine decreases, right, or actually I guess where sine is increasing, cosecant will decrease. Where sine is decreasing, cosecant will increase. And so here he is. Okay, same thing over here. where we have 1 divided by negative 1, or excuse me, yeah, but divided by negative 1 is negative 1. Where sine is decreasing, cosecant is increasing. Where sine is increasing, cosecant is decreasing. And this repeats itself in the negative quadrants as well. And so with just a few quick jottings, we have cosecant. I'm going to take the sine away. This is the graph of cosecant, remembering that we're using pi over 2, pi, 3 pi over 2, etc. Okay? And so that information comes in right here. We're still bounded by 1 and negative 1. We're still using the quadrant angles as our reference angles, but now we have cosecant. Okay? Let's move on to secant. And I have a feeling that many of you probably already have an inkling of what I'm going to do here. So let's make secant orange. Let's write let's see here. Let's write cosine in here because I didn't. Excuse me. Y is the cosine of x. And so we'll also do, we'll make secant orange. Just let's go crazy here, right? Okay, so secant is orange. All right, so just like with cosecant, secant is the reciprocal of cosine of x. So we get to use its graph to help us get started. So wherever cosine, is 0, secant should be undefined. And that's going to create some asymptotes in my graph. Okay, wherever cosine is 1, secant is also 1. So that's here and here and here. Where cosine increases, secant will decrease. Where cosine decreases, secant will increase. Whoops. Okay, and then where cosine is negative 1, so is secant. And that same pattern emerges. And so here is our secant graph. Whoops, wrong one. Here is our secant graph. Okay, using the same quadrant angles, using the same y values as cosine. Okay, tangent and cotangent are similarly related. Here is tangent. Let's write him in. I didn't give you a label for him, but we will. Okay, and we will make cotangent. What will we make cotangent? We'll make cotangent lavender. Whoops. And we know that cotangent is 1 over tangent. Now, tangent is our oddball so far, but these same general rules apply. Where the tangent is 0, the cotangent will be undefined. But we also get to say where the tangent is undefined, what do you think cotangent will be? Well, we can go back and look at our unit circle and see that tangent at pi over 2 was 1 over 0, and that's why it was undefined. If we flip that fraction over, we're going to get 0 over 1. And so instead of being undefined at pi over 2, cotangent will be 0. Okay? So all these places where tangent had an asymptote, cotangent is going to have a 0. And instead of increasing, where tangent increases, cotangent decreases. So where tangent is always increasing, cotangent is always decreasing. Now we're going to discuss in the following videos how some of that information may change. But for the parent graphs, we can be very confident in saying where one increases, the other decreases. Okay, we take away our tangent, and there is our cotangent graph. Very nice. Okay, and again, just like secant and cosecant have a period of 2 pi, tangent has a period of just pi. It only takes it pi to start to repeat itself. All right, this is where I'm going to end part 1. This is just the parent graphs, so you can flip through and look at them again. In fact, I'm going to go ahead and put them all on screen again so that you can kind of have some snapshots to leave yourself with. So here is sine. Okay, begins at 0 and oscillates between -1 and 1. Cosecant is the reciprocal of that. Okay, so you can draw it using sine and then take the sine away. Cosine begins at 1 and oscillates between 1 and -1. You can build the secant off of that and then take the cosecant away, or excuse me, the cosine away. Tangent always increases with asymptote at all the pi over 2's. Cotangent does just the opposite and decreases, but has asymptote at all the pi's. All right, so I'm going to pause it here and let you decide whether or not you want to venture on to the next video today or wait for another day. Hope you have a great one.